All right, let's head out into the deep cosmos. Today, we are visiting some of the most bizarre, logic-defying, and just absolutely fascinating planets ever discovered. Seriously, these are worlds that stretch the very definition of what a planet can be and totally challenge our understanding of how a solar system can even work. So let's just jump right in with a question that sounds, well, impossible. Imagine a planet thousands of times larger than its own star, but it's the planet doing the orbiting. How could that possibly happen? I mean, it feels like it completely breaks the most basic rules of gravity we all learned, right? Well, stick around, because the universe, as always, has a very surprising answer. So, here's the game plan for our little cosmic tour. We're going to start by exploring how these worlds even seem to defy logic. Then we'll visit a planet made of actual diamond. After that, we'll meet a world that literally survived being swallowed by its own star, stand under a sky with 3 suns, and finally, ask a really wild question. Could life actually thrive around a black hole? Okay, before we get to the planets themselves, let's tackle the big question hanging over all of this. Do these worlds actually break physics? It's a natural thought, but the truth is, it's even more exciting. These planets don't break the laws of physics. They push them to their absolute limits. And in doing so, they show us just how incredibly creative the universe can be.
And this is really the key takeaway for our entire journey today. These worlds might seem impossible, but they actually end up confirming our scientific theories, just in the most extreme ways imaginable. They stretch our imagination, for sure, but they don't break the rules. Let's see exactly how with our first stop. All right, first destination, a place called PSR J1719-1438b. This is the planet that answers that crazy question from the beginning. It looks about 3,000 times larger than its star. And you know, as if that wasn't weird enough, scientists are pretty sure it's not made of rock or gas, but of pure crystallized diamond. So here's the paradox, laid out plain and simple. You've got this enormous planet orbiting a tiny little star. How is the smaller object the one in charge here? Well, the answer isn't about its size. It's all about its incredible history and what that star actually is. So check out this wild origin story. This thing, it wasn't always a planet. It started its life as a star in a binary system with a much bigger partner. That bigger star went supernova, collapsing into an unbelievably dense neutron star. The star that was left over then evolved into a white dwarf, which is basically a super dense core of carbon. Then, the neutron star's immense gravity started pulling, stripping away the white dwarf's gassy outer layers, leaving just that carbon core behind. And the final step? Intense radiation from the nearby neutron star crystallized that core into a planet-sized diamond. So it all comes down to this. The planet only looks bigger. That tiny dot it's orbiting is a neutron star, the super-dense corpse of a massive supernova. It packs way more mass into a tiny, tiny space. Think of it like a giant beach ball next to a small cannonball. The beach ball takes up more space, sure, but the cannonball has all the mass. So the laws of gravity are totally safe. Our diamond planet was the unlikely survivor of a supernova, no doubt. But not all cosmic dangers come from a star's death. Our next world, Kepler 78b, is a survivor of a whole different kind of catastrophe, one that involved being swallowed whole. To really get its story, you have to appreciate just how extreme this place is. The surface of Kepler 78b is a blistering 3,600 degrees Celsius. That is so hot that its entire surface is just a permanent, bubbling ocean of lava. And this inferno, it's a direct result of its terrifying past. Just try to imagine this. Kepler 78b's host star reached the end of its life, and it started to swell up into a massive red giant. The star's gravity was so intense, it literally pulls the planet right inside of it, into its fiery outer layers. For any normal planet, that would have been it. Game over. Completely vaporized. But incredibly, that's not where the story ended. As the star eventually died and shed its outer layers, the planet emerged. All of its rock and its atmosphere had been totally burned away, but its dense iron core somehow survived the ordeal. What we see today is that scorched remnant, a testament to cosmic survival against just impossible odds. Okay, so we've survived the inside of a star. What could possibly be next? Well, how about a planet where the sunrise is a daily spectacle of 3 different stars? Let's take a trip to the system of HD 188753 AB, a real-life world that orbits inside a triple star system.
So you might be wondering, how does a stable orbit even work in a system like this? Well, it's this incredibly delicate dance. You've got the main star, we'll call it star A, with the planet orbiting it really, really closely. Then further out, you have two other stars, B and C, and they're orbiting each other like a little binary pair. And then that whole star pair orbits the central star and its planet. It's just a breathtaking gravitational ballet. And because this planet is hugging its main stars so closely, its year is incredibly short. It completes a full trip around its sun in just 3.3 Earth days. Can you imagine celebrating your birthday almost twice a week, all while watching two other suns dance across your sky? Okay, for our final stop, we're moving from the proven to the purely theoretical. But it's a concept that is just too amazing to ignore. We've seen planets around all kinds of stars. But what about the most extreme object in the entire universe? Could a planet, and maybe even life, exist in orbit around a black hole? And this isn't just science fiction. Scientists studying the huge clouds of dust that swirl around supermassive black holes have theorized that thousands of planets could actually be forming and orbiting deep inside them, totally hidden from our view. They've even given them a cool name, planets.
This, of course, is the big problem. A black hole famously consumes light. It doesn't create it. So for any of these hypothetical worlds to be habitable, to support life, they would need a constant source of energy for both heat and light. Where in the universe could that possibly come from?
Well, science has two very clever potential answers. The first comes from what's called the accretion disk. That's the swirling vortex of matter that's falling into the black hole. The friction in that disk would make it glow hotter and brighter than any star. But the second idea is even wilder. What if you could use the faint, leftover radiation from the Big Bang itself as a power source? This second hypothesis relies on this mind-bending phenomenon called gravitational lensing. A black hole's gravity is so intense, it literally bends space-time around it, which makes it act like a giant cosmic magnifying glass. So, in theory, it could gather that faint cosmic microwave background radiation left over from the Big Bang and focus it all into a powerful beam of energy, maybe enough to warm a nearby planet and make it habitable. So from diamond planets and cosmic survivors to worlds with 3 suns and even the wild possibility of life around a black hole, these cosmic wonders really push the boundaries of our imagination. But they don't break science. They show us that the universe is far more creative and surprising than we could have ever predicted, all while playing by the fundamental rules of physics. And that leaves us with one final thrilling thought. If these worlds exist, worlds that once seemed completely impossible, what else is out there? What other strange, beautiful, and logic-defying planets are just waiting for us to discover them? The universe is a very, very big place, and we've really only just begun to look.